Hey there, welcome back. So in this video, we are going to have a look at the negative bases uh, being raised to different exponents. In the previous video, we looked at what happens when you have a negative exponent or when you have a base that is being raised to a negative number. But in this one, we are going to have a closer look at what if you already have a negative base. And with a negative base, I mean that you have a negative, let's rewrite it right here. You have a negative a, and that is being raised to a power of n. And then, of course, what it and how n has an effect on the plus minus of your final result. So let's take a quick example. Let's take a few examples actually. So let's say I have a negative 1 raised to the power of 1. I have a negative 1 raised to the power of 2. I have a negative 1 raised to the power of 3, negative 1 to the power of 4, negative 1 to the power of 5. So, and before we begin, let me update your memory if you don't know already. But if you have a positive number being multiplied with a negative number, you get a negative number. If you have a negative number being multiplied with a negative number, you get a plus number. And of course, a plus number being multiplied with a plus number, you get a plus number. So keep this in mind once we're solving these exponentials. So I'll repeat. If you're multiplying two numbers and one of them is a positive and the other one is a negative, you get a negative number. If they're both negative, then you end up getting a positive number. And if both of them are positive, then you again get a positive number. So negative 1 to the power of 1, that is of course negative 1. Negative 1 times by negative 1. So we have two negative numbers. That would give me a positive 1. Negative 1 times by negative 1 times by negative 1. So a negative negative, that we know gives you a plus, but a plus multiplied with a negative, that gives you a negative number. But now we are going to multiply negative 1 with itself 4 times. So negative negative, that gives you a, let's make a note, so this gives you a positive. Negative negative, this also gives you a positive. So a positive positive, that would give you a positive number. Now we are going to do the same thing. One more. Oops. So there's 1, 2, 3, 4, 5. Now we know that if something raised to the power of 4, that was a positive 1, then positive 1 multiplied by negative 1, that actually gives you a negative 1. There. So there must be, there's a very quick trend that you may have already noticed. If you're raising a negative base to a odd power, then you actually get a negative answer. If you are raising it to an even power, then you actually always get a positive answer. And that essentially is the main highlight that we need to look at. In other ways, so if minus 1 is, now of course we used minus 1, but it could have been any number in between. You could also have written minus 2 or minus 5, minus 6. The same rule applies to all numbers as long as you have a negative number, as long as the base is negative. So you have a negative 1, negative 2, negative 3, negative 4, negative 5. So there was a negative 1, 1, so negative, positive, and negative. Now you may be wondering why it is that is happening, right? Let's have a quick look at a number line. If I can draw it straight, well, that's the best I could do. So you have a 0, then you have a 1, you have a 2, you have a 3, you have a 4, you have a 5, and you have a 6, 7, let's take it, let's go up till 8. You may have heard of these sinus and cosine uh, curves. We're not going to go in deep into that, but this definition actually applies most when you're working with those curves. But at the same time, you also have a very important use of this when you are working with normal exponential functions. But just to get you a quick just to give you a quick idea of how it actually looks like, is that if something every time you have a negative, what I'm going to do also is I'm going to write a negative one there and a plus one there. So of course, if something is raised to the power of a 0, we know that is a 1. We know that the what's it called, the oops, sorry, there all of the odd numbers, they give you a negative answer, and all the positive numbers, they give you a positive answer. And then there we go. So essentially what you're looking at is something that looks something like this. You end up, oops, that was a very badly made curve, but you get the idea, right? And you can actually use this definition on any of the numbers that you are working with. Using the same idea, because now we only looked at positive integers, but just like we saw in the previous video, you can also have negative integers. That means that you would have something with 1 over to the power of a negative 1, minus 1 to the power of a negative 2. Now let's think for a second, does it actually matter? Like for example, if I write here, that needs to be a negative 1 instead. Negative 1 to the power of a negative 2 instead. Just like we saw in the previous video, what it essentially means is just negative 1. What this means is that it is to the power of a negative 1 times by a negative 1. Then you would actually end up getting what? 1, and then you get a positive integer. In this case, you get a negative integer, negative number. So in reality, it doesn't matter what's the sign of the exponent. The only rule that you need to remember in this case is that for let me quickly rewrite it. For a negative a to the power of a n, if your n is odd, well then your answer, and let's just say the answer is b, then your answer b will actually be a, sorry, if it's odd, then your answer will be a negative number. If your n, which is the power, is a even number, then your answer will be a positive number. And that essentially matters, regardless if n is a positive number itself or a negative number. So that means that regardless if you have a positive power or a negative power, the answer remains the unit of the the plus minus sign of the number remains the same. Of course, the answer itself is not going to be the same, because if I had replaced this with a 2 instead, and let me just actually, just so that there's no doubt, for example, if I had written minus 2 to the power of 1, minus 2 to the power of 2, then this, as we know, is 2, and this, as we know, will be minus 2. 2 times 2 is 4, but they're negative, so it's 4. On the other hand, minus 2 to the power of a negative 1, minus 2 to the power of a negative 2, that would actually just be 1 over minus 2, so a minus a half, oops, sorry, minus 1 over 2. On the other hand, if I had this one, then it would actually just give me 1 over 4, right? So the answer itself is not the same, of course, but what we're talking about here is the signs of your numbers. So as you can see, this is still a minus and that is a negative. So this rule more or less applies to whenever you're working with a negative base. Just remember that, keep this in mind when you try to solve any equation that you may get in exponentials. Great. And I really hope the video was helpful. And if you did like it, if you did find it helpful, then do remember to like the video and also subscribe to the channel for more videos on different topics. Thank you.